Alright, get it to it after. Okay, grade 10. So we are busy with circuits. We are busy specifically today, starting with the two types of circuits. We have discussed a series circuit, where we said the current is the same throughout, because it can't divide up into different places. But the volts, the sandwiches, the energies are split up. Yes, you remember that? And then we said when you plan for the day, you think, I have to do this and this and this. Okay, so that's why you add the resistors together. Okay, now let's look at the example. Normally in an exam, it will say, consider the following diagram. Then you need to consider. Okay, so you take here, you take your highlighter, you say, okay, here I walk, I have to pass through that one, and that one, and that one, and through the ammeter and back home. So the current can't split up anywhere. The current is the same everywhere. And if you look at that ammeter measures the total current. Are you making notes? Are you highlighting? Then if you plan your sandwiches for the day, you are going to say, all right, I have 6 sandwiches here. I'm going to split up my sandwiches. I'm going to look, okay, some needs to go to life orientation, some needs to go to English, and some needs to go to mathematics. So your sandwiches you're going to split up. Are you going to split them up equally? No, because the resistors aren't equal. Okay, now let's read the question. It asks, calculate the reading on the ammeter in the circuit. So where's the ammeter? There's the ammeter. What does it measure? It measures the total current. Okay, so they are basically asking us to determine the total current. To calculate the total current, we will need the total volts and the total resistance. Genevieve, what is the total resistance? How did you get to 18? You add the resistance together because they are in series with one another. So then you just normally add, because you said I have this and this and this. So you add them all together, and so the total resistance is 2 plus 4 plus 12, and that gives you 18 ohm. Karabelu, what is the total volts? 6. Okay, now the formula that's on your data sheet is R is equal to V over I. You always write down a formula exactly like it is on your data sheet. Then you substitute your values. Okay. Now Karabu, my question to you is, this current that you want to calculate is underneath in the fraction. You don't want it there. How are you going to get rid of it? Okay, and then? What are you going to do with the 18? So you say basically we have I times 18 gives you 6. What by what? Huh? I see that. Karabu, this is the same as 18 over 1 is equal to 6 over I. How will you solve this problem? But then you still multiply. If you multiply 6 here and you multiply 6 here, then you have 6, 8, you have 102 is equal to 36 over I. Yes, what option do you want to use? Audience, I am here. What is she going to do? Yes.
I'm thinking times the denominators and times the denominators together.
Can you do that mathematically? I don't think you can. Adlia?
I think you want to divide 6.
So here you have 3 and here you have 1 over I. Ladies and gents, grade 8 mathematics, if you had 20 is equal to 100 over x, how would you solve x? If you had 20 over 1 is equal to 100 over x, how would you solve x? The thing that you want is underneath the fraction. You don't want it there, you want to get rid of it. How do you get rid of it? Okay, so there's now 3 methods that I can think of what you can do. Okay, the one that I prefer to say, I'll say you crisscross. You take this, that side, and this, that side. So that you have x is equal to 100 divided by 20. Huh? Because technically, okay, I just want to delete here. So, if you say you want to get rid of this I, you are going to multiply to get rid of it. Okay, to get it at the top. So, you have I times 18 is equal to 6. So, you took times I. Yes? Now, you want to get I on its own. You want to get I is equal to blah, 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 blah. So, what are you going to do? You're going to get divide by 18. What you do on the one side, you must do on the other side. So I is equal to 18 divided by 18. So what did you do? You crisscross. Yes?
Please explain it again.
Guys. I'm going to explain with other values. If you have 100 is equal to 20 over x, you want to get x. So, but at the moment x is underneath the fraction. You don't want it there. You want it at the top. Otherwise, whatever you do, you get 1 over x, and you don't want that. You want x. So first of all, you want to get x to the top. How am I going to do that? Multiply with x on both sides. So you have 100x is equal to 20. Now you want to get x on its own. So you get x is equal to blah, blah, blah. What are you going to do? Divide by 100, divide by 100. So you have x is equal to 20 divided by 100. So basically, that is the same as saying 100 over 1 is equal to 20 over x. What we had at the beginning, that. And then to crisscross. Take the x to the top, take the 100 to the bottom. All right, so we have current is 6 divided by 18. And, Karabu, in your head, 6 divided by 18 is what? 18 divided by 6 is what? 3. Yes. And 1 over 3 is the same as 0.333333. And the unit for current, Karabo? Actually, stupid me. Yeah. A stands for? Thank you. Yes? Yes. All right. Now we're going to go to a parallel circuit. Okay. So here you walk. Wait. Everyone needs to pass through that ammeter. So that ammeter measures the total current. And then you have a choice. Okay? Let's say your choice is either science or business or life sciences. Okay, so then you have a choice which path you take, and then they get together here and they pass through the cells. Right, now let's say, you chose, you start the day with 10 sandwiches and you chose to go to science. How many sandwiches do you have before science? And afterwards? 10. So you use nothing for science. Science is easy peasy. Say again? Where do you go after science? Are you allowed to take food home? No. You must eat everything. 0. So how many sandwiches did you use in science? 10 sandwiches. Okay. Sizwe, you chose business. Here you walk. You go to business. Before business, how many sandwiches do you have? 10. Afterwards?
0.
Why?
Because I'm going home.
So you get 10 more. So you used 10 sandwiches. I will be with you in a moment. Amara, you chose life sciences. Before life science, how many sandwiches? Afterwards? Why? Because you're going home where you get 10 more sandwiches. So that is 10 sandwiches. Yes.
So isn't it in one day? Before home you go to life sciences, then business, then
No, you chose one. You choose one path.
one part.
One path. You can't go from there. Okay. So can you see that resistors in parallel have the same voltage? Why does it have the same voltage? Because it's different charges. I asked different learners. So we can say here there's 5 learners, here there's 10 learners, here there's 20 learners. Okay? The number of learners can change. That can be different. But how much energy each learner has is exactly the same. Okay? So the current, how many, is different, but the energy per person is the same. Alright, so we have here that the potential difference, the volts, over each branch is equal to the potential difference over the whole circuit. The volts stays the same, basically. But what happened to the current is the current was split up. It was current dividers. So the current split up from the total current into each branch. So we say the sum, what does sum mean again? Plus. The sum of the current through each branch is equal to the main current, the total current. Okay, now when we did this, it's not you had science and business and life science, you had three things. You didn't add them together. You had to say this or this or this. So it makes it life much easier because you only have one subject whole time. So we can't add them normally, this one plus this one plus this one. You're going to add them using this formula here. 1 over r parallel is 1 over r1 plus 1 over 2. We're going to see how we use them in a moment. That formula is on your data sheet. Yes. Anything blue? What do you mean? Because it seems silly to highlight anything there. To me, you can if you want to. But remember, this is not a coloring book. Alright. Normally the question will be, consider the diagram. So that's what we're going to do first. Look at it. Consider it. You see here, you walk with 6 sandwiches. Okay, there you walk. Everyone must pass through that ammeter. So that ammeter measures the total current. Then you have a choice. Are you going to go to between life science, physical science and business? Which one is the easiest? It's the easiest. I won't be, I'm just, all in favor of business, put up your hand. 7. Okay, so that is the most. So you have a choice. Are you going to go through business or which one is the most difficult? Okay. Or are you going to go to double physics or are you going to go to life sciences? So that's your choice. Okay, you don't have to do all three, only one. Either business or double physical or life science. And then you go back home where you get 6 more sandwiches. Really. You choose business. How many sandwiches do you have before business? 2 sandwiches.
How many is the total?
You tell me.
6.
6. After business, how many sandwiches do you have?
0.
So for that one, you have 6 sandwiches. To me, you choose double science. Before double science, how many sandwiches do you have? After?
0.
Between? 3. 1. So you have 6 sandwiches for double science. And Asina, you choose, what did I say? Life sciences. How many sandwiches before? After? So that is 6 sandwiches. So each branch has the same number of sandwiches. That does not mean it has the same number of charges passing through it, men passing through it. Okay, now that I've considered it, now I'm going to read the question. Now you're going to have to divide your page up into 2. Okay, let's calculate the reading on the ammeter. Where's the ammeter? There's the ammeter. What does it measure? It measures the total current. Okay, so they're basically asking us, you must go determine the total current. That is the question. For total current, you need total resistance, total volts. Umulemu, what is the total, or can I, for the total resistance, say 2 plus 6 gives me 8, plus 6 gives me 14, plus 4 gives me 18. Why not? Say again?
You should use the middle one as 1.
Okay, so this is 12. So can I say it's 2 plus 12 plus 14? Because you're not going to go through each one. You're going to have to choose one. So your total resistance for the day isn't 80. Your total resistance is one of the branches. Okay, so how are you going to calculate the total resistance? You're going to use this formula here. Yes.
So the point chooses like one of the
Paths. Okay, so we have 1 over R parallel is 1 over R1 plus 1 over R2 plus 1 over R3. But at lehang 1, 2, 3. Ne? 1, 2, 3. And here we have 1, 2, 3, 4. Shouldn't I say plus R4? Why not? You can only ask Umulemu. If you struggle, you can only ask Umulemu.
I think you should add the 6.
The two sixes are in series with one another. And if resistors are in series, like there, you just add them together normally. So because they are in series with one another, this will be considered one resistor, one path. Okay, so this is 12 ohms together. So we have 1 over 2 plus 1 over 12 plus 1 over 4. So each branch. Okay, and that gives you 10 over 12. Ne? Yes? Yeah? Common denominator.
So we have to take out the common. It's 12. And then like times.
Or you type it into your calculator and you will get 5 over 6. Same. Alright, now what we've calculated is 1 over R parallel. That's not what we want. We want the total resistance, not 1 over R parallel. Okay? Dummeling, if I owe you 100 Rand, is it the same as saying I owe you 1 over 100 Rand? Is it? Great stuff, then I only owe you 1 cent. So no, they are not the same. Type in your calculator, 100 equals to, and again you get 100, ne? Now type 1 divided by 100. That gives you what? Press SD. 0, 1. So are they the same thing? No. So we can't say this is the same as this. It's not the same. We want R total. We want the R to be at the top there. We don't want 1 over what. So we are going to flip them around. But what we do on the one side, we must do on the other side. So we have R parallel is 12 divided by 10. So we flip them both. And that gives you, without a calculator, Genevieve, 12 divided by 10. If I said 120 divided by 10, what would you say? So what is 12 divided by 10? Wait, 1.2 ohms. Alright, now, we said if things are in parallel with one another, Then you have a choice. So it makes your life much more easy. Imagine you had to do business and then 2 periods of science and then life sciences. That's a bit unfair, right? It's much easier to just choose one of the paths. So that's why we didn't add them normally. We did this whole thing. And then you get an answer, a small answer, because life is easier if you have choices, right? And how do you know your answer is more or less on the correct path? If your answer is smaller than the smallest one in parallel. Is 1.2 smaller than 2? Yes, so that is how you know your answer is more or less on the correct path. Yeah.
So if you choose 1 million, is it the same? Then you calculate everything. Is it also the same as the business? Like the answer.
Okay, ask your question again.
Can you remember we chose the physical sciences part? If we would calculate the business, would the answer still be the same as the physical science part?
What answer to what question?
The total, yeah, the ohms,
No. So the ohms for the total circuit is 1.2. But the ohms for this path is 12.
then it's not going to be the same as
This path is 2. Alright. Now we haven't answered the question yet. We've only answered it halfway. We have 3 out of 6 marks. We've calculated the resistance there is 1.2. So that is that. The question was, what is the current? For that we need the volts. Karabelu, what is the total volts? It is 6. Okay, so now you go to your formula. Resistance is volts over current. The resistance is 1.2. The volts is 6. The current is I. Karabu, again you! How are we going to calculate the current? Current is what? What are you going to type in? What are you typing in? No. The rest of you knows. Because they are not stressed. You feel stressed because it's your question. Why do I do this? There's 2 reasons why I ask everyone a question the whole time. I don't do it because I'm bored or because I like to put you under stress, blah, 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 blah. So I make sure, So I make sure, why Siri? I make sure that you guys are with me. So I see you when you are not with me. And number 2, what? Then I see I have to explain something again. You'll see I get up from my chair. What's the second reason? Yes? Yes, because science, you are going to stress when you write exam. And you must learn to think under stress. Are you stressed when you know your question is coming? Yes. Do you stress before you write a test? Or when you Yes. To teach you to deal with that stress. I'm going to stay here. I'm going to ask the question. Whether you're right or wrong, I will help you then. Karabu, are you ready? You want to call someone? Okay. Remember, this one goes up, that one goes down. Yes? 5 what? 5 amperes. Okay, so what you calculated there is the current. You calculated how many men. Okay, so it's not really how many electrons there are. It's not the coulomb. Okay, it is just, in our story, how many men is walking through our circuit? 5 men. Yes.
What if the photons were able to move?
Then we would have an atomic bomb. All right. So we have 5. So that is, the reading on the ammeter is 5. Now they ask, calculate the current in each branch. So how many of the 5 men chooses to go through there? How many chooses that? How many chooses that? Okay, so we have to look at a branch at a time. So let's look at the 2 ohm branch first. Okay. Let's say what? Okay, we want to calculate the current. They want to know what is the current. What is the volts for the 2 ohm branch? 6. Sizwe, what is the resistance of the 2 ohm branch? 2. Trick question. Okay, now, if you didn't ask a question that I was hoping you would ask, ma'am, isn't it just easier from here to first rearrange? To say R is V over I. So right, I need I, so then it's I is equal to V over R. Okay, yeah, I didn't ask that question. Did you think of it? No. Okay, now you are wondering why not. If for whatever reason you are stressed and you rearrange incorrectly, so you from there you say, okay, I is equal to V times R. You do something wrong, you get that. And now you substitute 6 times 1.2 and you get that to be 7.2. Then you get 0 out of 4. You don't get a mark for the formula or substitution or your answer. But if you do this, you get a mark for that. And then, luister die hele video, foto. Oh, ek dink hulle luister die onder. So there's a whole from his other's class to my class. And we can hear what they say. Alright. Do you hear that? Okay. So, you get a mark for the formula. Then you get marks for substituting. And then if you rearrange incorrectly, then you only lose 1 mark. Okay, so that's why you do not want to rearrange your formula at the beginning. Because if you do it incorrectly, you will get no marks. Alright. But I'm going to be naughty now and I'm quickly going to rearrange because I have not enough space. So current is volts over resistance. The volts is 6, the resistance is 2. Amara, quick mathematics. 3 what? Amperes. Alright, now I know, really, if it makes sense that of our 5 men, we only have 5 men in our circuit, 3 of them goes to that branch. Does it make sense, yes or no, and why? We have 5 men in our circuit. Of the 5 men, 3 of them goes through the 2 ohm branch. That's what we've calculated.
And 5 is for the total, right?
5 is for the total current. Then of that 5, 3 chooses to go there. Does it make sense? And why? Of the audience, call a friend.
Ask the audience.
Audience, anyone? His R1,000,000 is in your hands if you answer. Yes, I'm going to take out R1,000,000 from my pocket and answer. Carabello?
Wow. Ma'am, is it because 2 is the right? This is no.
So you say it does make sense?
Yes.
It does make sense, yes. So congratulations, you're over 500. It does make sense, yes, because it has the smallest resistance. It is the easiest path, the biggest amount of kids will choose that path. Okay, yes, is that true in life?
Yes.
Alright, So because it's the smallest resistance, the biggest, 60%, 3 out of 5 is 60%, chooses to go through that path. So you see, it does make sense. Alright, now we're going to go to this 12 ohm branch. Okay, now I'm not even going to write down a formula, I'm just going to substitute values. To me, what is the volts for the 12 ohm branch?
60.
And the resistance is what, Asina? And quick mathematics, how much is that, Umbelemu?
1/2.
Which is a half. Let's see, does it make sense that a half a human, someone without a head, chooses to take double science? Yes. Because why would you choose to do a double science with 6 sandwiches where other people can go to business with 6 sandwiches? Okay, so it does make sense that the bigger resistance will have the biggest resistance will have the smallest current. Now, Atlihang, without doing any such calculations, what is the current through the 4 ohm branch? And I will give you help. So this is your 50-50. This reading was 5 amperes. Of the 5, 3 goes here and 0.5 goes there. That's a lot of help that I just gave.
What's the question?
What is the current through the 4 ohm branch?
Maybe can I ask it again?
No, because I already gave you 50-50. So I'm going to say this again. Of the 5, 3 goes there and 0.5 goes there. I want to know how much goes there. Hoeveel? No, 2.5. Boom, 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 you lost. Karabu, how did you get to 1.5? You had 5 men, 3 went to the first branch, a half goes to the second branch, so you have left a half and 1. You see? You had 1, 2, 3, 4, 5 men in your circuit. 3 of them, doom, 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 chooses to go through there. A half a man chooses to go through there. So how many do you have left? 1.5 to go through there. Alright, so the current through the 4 ohm branch is 5 minus 3 minus 0.5, and that gives you 1.5 amperes. Yes? Okay. So great ends, I'm going to give you time to start with your homework now in class. Your homework is the whole of page 8. So question 1, 2, 3, 4. Yes. Do I give homework every day? No. Alright. Then grade 10s, the answers to the questions is on page 10. There is the answers. So you can mark yourself. So you know you're on track, and then tomorrow I'll ask who struggled with question 1, meaning who did not get to question 1's answers. And then we'll mark together.